Welcome, Ceci, to your class. Everyone in China, I'm going to try to record this for you, and we'll see if it works out. Okay? All right, so like I said yesterday, number one thing that we're going to talk about in calculus, the first thing is going to be limits. It's going to be the first of those three that you have probably never encountered before. Okay? This to go away. All right, so first thing is limits, right? So you can see the definition I have on the board, and you can see that I've tried to do everything approach. So let me ask you, do I care what happens when you get there? No. You have no idea how little I care what happens when you actually the idea is that the value of a function approaches as you get closer and closer to some point. Now, when we say the value of a function is approaching, okay, you might just want to make a note and say, I've made the note. The limit could be different at that point, okay? We'll get some examples of when that happens. Have to be. So this first one that I have on the board right now is the limit as x approaches 3 of 2x, okay? And it equals 6. So that's the way you would read this. The limit as x approaches 3 of 2x. So you start at the top, with the limit, and then you drop down. X is approaching 3. That's what the arrow means. So there's just a simple little arrow there. And you have the function out at, okay? As x is approaching 3, so here are my x values, right? And my x values are approaching 3, so they're getting closer and closer to 3. If you would just imagine that I have walls coming from both sides, right? And what I'm saying is that these, let me get them individually here, right? So this one is approaching, it's going to approach 3. It's going to get closer and closer and closer to 3. And then there's one on this side as well. And this one is also going to approach the 3, if I can get it. It's going to approach the 3, right? So the idea is that those two things are squeezing in on 3, okay? The x value 3. They're getting closer and closer to it. At that same time, you can see from our line right here that there are y values, okay? And so when my two walls are way out here, the range of y values that are in between there, let me get this one to match that right there, and down here. So you see the range of y values is all the way from this bottom line to this top line right now. So as I come in, now these y values are down here, right? And as I come in from the other side, now these bottom y values have moved up here, right? And so the whole idea behind the limit is I'm walls from the left and the right closer and closer and closer. And when I do that, those walls on the top and bottom are going to get closer and closer together, right? And so what we're talking about is you can see it from the graph is what? Yeah, it's the y value 6. So that's why the answer is 6. Okay? Algebraically, it's much If you take the 3 and plug it into this function, what are you going to get out? 6. So is there any surprise whatsoever that our y values are getting 6 as our x values get close to 3? No, should not come as a shock, right? Okay, so that is the concept. All right, here's a couple more. Will somebody read this? Read the first ones for me. Let me get a volunteer. Anybody? Already? No, you're right. The limit as x approaches 0 of, and then just read that like you would in cube. Great. All right, so the limit as x approaches 0 of 2x cubed. And you can see the here, right? So if I made my walls here and I started to squeeze them together, right? What kind of y values are in between there right now? What y value does it look like those two things would be zooming in on? 0. That's exactly right. And then once again, algebraically, this is not difficult. If you take the 0 and plug it in, guess what? You would get a 0 out. Just a little while. So these, please think this limit right here is. -3. How'd you get that, Avery? Looked at the graph. Did anybody do anything else? Take -1 and do what with it? Plug it right in for x. What's 5 times -1? -5 plus 2, -3. Easy peasy. Right. Option. You may want to write this down. Your first option whenever you're trying to solve a limit is to just plug the number in. Right? Just plug the number in and see if that works. If it does, it's your lucky day, right? If you can just plug the number in and it works, it's great. Whatever you get out in most situations will be okay. Here's the thing about calculus, though. Like, I can't say that will always circumstances that surrounded it can't be a function like this, and you plug in and you get a number out, you're good. Okay? So here are a few practice problems. So you can work these on your own. So go ahead and write them out. You may want to practice if you. No more. And I can move down and blow it up some more if you need me to. But it's the limit as x approaches pi over 2 of sine 3x. X is approaching pi over 2. All right, we got answers? Okay. I just want to make a notational point here. I want to make a point about the notation. If the situation over and over and over again in calculus, that's always the case. You can simplify. And you keep writing that limit sign, and then once you've plugged in, you can drop it, okay? So for this one right here, the first thing I would do is plug in the -1. And notice that I plugged it in, so I didn't even write the limit as x approaches -1 anymore, because the -1's already in there, okay? And so at that point, that's when you can drop the limit. And so this is -6 minus 5, which is -11, okay? Hopefully that's what everyone got. For this one, it's just 2 squared, which is 4. Here we have -1 to the third power minus 4 over -1 plus 2. Okay. So this would be a 1 on bottom, and then that's a -1 on top and a -4, which makes a -5 when you put them together. So -5. E times pi over 2. So that's the same as the sine of 3 pi over 2. Yeah, 3 pi over 2 is where? Straight down, and so the answer is -1. Very good. Okay. No problem so far? Everybody good? Okay, all right. Now the fun begins. Okay, so what I have on the board right now are 3 examples of limits. Okay, 3 examples of limits. And they all have the exact same limit. Okay, these are 3 different equations. You can see this one is kind of a piecewise function, but all of these have the exact same limit. Okay, so you may want to write these down. Can you see what they have right here on this one? Can you tell what it has? Yeah, it has an open circle. So let me just kind of magnify this one for the time being. Okay, so at this point right here, it has an open circle. Which does you studied this in pre-calculus? What does that mean is there? Yeah, at that point, it doesn't. The function doesn't even exist at that point. There's a hole in the function right there. Okay, and that's actually at it's this function right here that gives that graph. Here's the thing: take that 1 and plug it in, and tell me what happens. Over 0. You get a 0 on bottom of a fraction. 0 on bottom of doesn't even exist at this point whenever you plug a 1 in. Are we concerned with that? When you get there, the question is, what are you? Can you look at the graph and tell me what y value you're getting really close to? You kind of imagine yourself riding the line along here, and you get to squeeze in as close as you can. So these x values are coming in, and as they come in, what are the y values going to? Yeah, they're going to 2. The answer's 2. The point is not down with the hole, but let me just show you why it works, okay? Remember I said you can simplify before you plug in, right? How can you simplify this right here? Good. Does everybody see that the top is a different, and so this is the limit as x approaches 1, and this top can factor into x plus 1 times x minus 1 all over x minus 1. Everybody with me there? Don't remember how to factor like that? Yeah, a few people do. Yeah. So, do you remember having like x squared plus 2x plus 1 and having to factor that into two sets of parentheses? All right, well, the rule is whenever it's something like this, if both of these numbers are squares, this one is 1 squared, this one is x squared, then it turns into x plus this one and x minus the same number, right? Okay, so that's all that's going on there. So we factor it down, and now, once we've done that, the x minus 1s can cancel. And so this function is, in reality, equivalent to x plus 1, right? See how I keep my limit, right? Because I've been simplifying stuff. I haven't plugged in yet, so I'm keeping my limit. X is approaching 1. And now I can take that 1 and do what with it? Plug it in, so I'm going to drop. I'm not going to write my limit down anymore. And the answer is 2. That's correct. There will be a lot that will happen that way. The second one is actually really straightforward. It's the simplified version of the first one, right? The limit as x approaches 1 of x plus 1. And you can see that one, this one's 2. A combination of the first one and just a little addition to it. Let me get my dot, right? Okay, so here's this. I want this to go here. That's about where it would go. Right? And so all this piecewise function is saying right now is that we want to use this function. So that's the line with the hole in it, right? So we use the line with the hole in it. And does everybody know what this means? X is not equal to 1. So anywhere where x is not 1, we're using. That's when we got the 0 over 0 earlier, right? And so all this, use it everywhere. So when x equals 1, that's where the hole is. We just want you to put a dot at 1. That's all it's saying. So when it's there, just put a dot at 1. So you just have the point 1, 1. And the rest of the time, you're using the line that comes from the top part of the graph, right? Okay, so I just wanted to show you this so I can make a point. Two. Okay, maybe compare what happens when you actually get there. No, when you get there, it actually. So when you actually get to 1, then it ends up being 1. As we're on the line and we're headed towards the x value 1 on the line, right? The x value 1. So we're just moving these walls in right here. And so we keep moving those walls in to get a little closer and a little closer. And as we get them a little closer, they keep squeezing together, and the y values have to come down together. And those y values are coming around the y value. The thing is, okay, you never actually get there. But the question is not what happens when you get there. It's where do you think you're headed, right? So if you can imagine like you're in the car with somebody and you're on 82, right? 45 alternate, okay? And you're driving and somebody asks you, where do you think you're going right now? What would you say? You know where 82 goes if you go past? it stopped. It never even made it there. And then it turns out, if you could teleport, right? You get right outside the Columbus city limits. When you were coming from the other direction, all signs indicated that you were going to Columbus. Exactly. Yeah. Okay. You want to write this down because there's a. Make this bigger. I'll make this bigger. Make this bigger. Let me blow these up a little bit so you can see them from the back, right? Okay. So there are two different limits. And this, there's a road having whenever you're headed to a place. Okay. And so we have two. You'll notice that the setup is exactly the same. This is the limit as x approaches and sees the variable, right? So, but the only difference is plus means right. Yeah. On the right-hand side. And then the left-hand limit is just signified by the minus sign on the back of the number. Now, don't see the minus sign, right? Okay. So right-hand limit has the little plus sign. We're coming from the right. The left-hand. Which direction are you actually moving? Left. And if you're approaching from the left, you're actually moving to the right. Okay. So you want to start on those sides and then the truth. Okay. A limit only truly exists if the at some point C, if and only if, only true, if the right hand and the left hand limits exist and they are equal. It can really. Everybody got that? Okay, if I'm. All right. if I was coming from the left or from the right, for every one of these that we've done before, they're headed at the same point, right? And then the same thing here, they're headed at the same spot. And then even with these here that I've scribbled all over, right? Even this one that had the hole in it, okay? If I came from the left and the right, they were headed at the same spot, okay? So all of those have existed because the left-hand and right-hand limits have been the same up to this point. Now, this may be a little different. I'll really quickly sketch this graph on your piece of paper, okay? So take just a second and sketch that. Can get those written down without too much trouble. Yeah. Just to make it easy. See, and you killed it. Yeah, that's all it was. Sorry, Ceci, I was talking to Cameron. So all the limits means the left-hand limit. I'm going to start by writing the limit as x approaches 0 from the left. And since this whole thing is called f of x, instead of writing all of this out, I'm just gonna signify that we're talking about this function by writing f of x. Okay. So the limit of this whole function f of x that you see here from the left, and let me go ahead and give myself a right-hand one as x approaches 0 from the right of f of x. And then we have the overall limit, right? Just the limit as x approaches 0, no specifications on direction. Okay. So remember, for this third one to actually exist, okay, the we want to get on the line over here, you know, and then I'm going to go towards 1. But there's a small problem. What's the problem? There's no line, right? No. So what do we have to say about the does not exist, right? That one does not exist. The right-hand side of 0. So here's 0, right? I'm going to move over to the right just a little bit. You don't have to move too far. And I'm going to get on the line, and I'm going to ride it. And then I'm concerned with what y value I'm headed towards as I come from the right-hand side. What y value am I headed for? 1. Does everybody see that? So the right-hand limit is 1. That's the y value, okay? Don't get all the way over here, right? Don't get on it and try to ride the line, okay? You don't want to do all that. You just want to get right next to it and see what's happening, okay? Because we're approaching what number? We're approaching the x value 0, and the x value 0 is right here. So I'm getting over here, and I'm headed toward the x value 0, that big wall, and the concern is what y value am I going to? And the answer is 1, so it's 1. At the x value 1, so the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, and then just the limit as x approaches 1. And these are all for the function f of x. So let me not forget my notation. Okay, so this is the x value that we want to approach, right? Right there at 1. So I'm going to come from the left. And so when I come to that x value and I'm on this line that's coming from the left, what y value am I headed for? 0. Yeah. And now I have to get on the right. So let me get over here on, like, so here's I want to approach this place right here, but I got to come from the right. So I got to get on this line. And as I come on this one from the right, what y value am I headed for? 1. Yeah, 1. That one's headed for 1. So from the left, I'm headed down here to 0. From the right, I'm headed up here at 1. Okay? So what does that mean about just the regular limit right here at 1? Yeah. It does not exist. Oh, and I forgot to do it for the 0, right? This one would also not exist. Because they don't match. Exactly. All right, so let's so we got the limit as x approaches 2 from the left of the function, the limit as x approaches 2 from the right of the function, and then just the limit as x approaches 2. So on the left-hand side and go towards 2, what y value are we headed for? Huh? Yeah, just get on the line and go towards it. You're headed for the y value 1. Okay. And now we want to approach from the right. So if we approach from the right, now we're on this line and we're riding towards this x value, but what y value are we getting close to? 1. So the limit from the left is 1. Now, let me ask you this. Where is the function? If I asked you for f of 2, what would you say? It's actually at 2, right? But the limit is at 1. Okay?